Hello, my name is Jana Hucker. I am currently taking a course at Career Foundry to transition into a data analytics career. And in this video, I will be going over several questions that might be asked in a data analytics interview. So, without further ado, let's get started. Question one. What does the CRISDIA methodology for data mining entail? And what does the data analyst do in each step? So number one, CRISDM stands for Cross-Industry Process for Data Mining. This is a structured approach to planning a data mining project that's used, like it said before, across all the industries. So it is now the most common method for data mining, and yeah, it is used in many industries right now. Let's see. Data mining, it is the practice of analyzing large databases in order to generate new information. This is a little different from data analytics, which is testing a hypothesis. Uh, so in this data mining, you have to kind of figure out which variables you might need and to match the insights that you will be want that you will be creating that will help your client or the company that is asking for your data analytics services. Uh, so, as you can imagine, it is very easy to get unorganized and waste a lot of time if you don't approach this in an organized fashion, an organized step-by-step process. So, in order to keep it organized and not waste any time, we have this CRISP-DM methodology. Oh, it's also good because if we have a standardized approach, we can improve on it gradually over time. Because everyone is doing the same thing, and everyone will find different ways to make the process even better, and then we can share that, and all together we can slowly make this process better and better over time. And that is pretty cool. All right, so anyways, CRISDIA method has 6 phases. And next I will be telling what the data analyst does in each phase. The first phase is the business understanding phase. Here, you want to make sure you understand what the customer really wants to accomplish. So, for example, do they want to optimize their prices to get the most profit, and maybe optimize their prices to get the most loyal customers, or increase customer retention, something like that. I'm not sure. Whatever they want. So, another example is finding bottlenecks in the supply chain. So, for example, if you have a lot of demand, but you can't quite get the right supply to fill it, or the right price supply to fill it, maybe you can run a data analytics process to find those bottlenecks and make sure you have enough supply. In this phase, you also want to determine what resources you have. So these will be like what data sets you got, or what data sets you have, what data sets you're working with. You also want to make sure you have access to contacts, or you know who collected the data, and you know who you need to contact if you have any questions about anything. Um, you also need to consider the risks of this project. So this can include, usually includes data ethics risks. So in this phase, if you can kind of get your mind around what possible risks you might be encountering, or what possible risks might come up, then you'll be more able to recognize them in the following phases, and then able to jump on it and do something about it. So there is that. Phase 2 is the data understanding phase. Here, we are going to identify, collect, and analyze the data sets. So here, you're going to see if the data is clean or dirty. You're not going to clean it in this phase, but you're just going to see how it is, see the quality of the data. You will want to do a little descriptive statistics on the numerical data, find the max, mean, minimum values, stuff like that, and the categorical data, see what categories there are supposed to be, and then maybe run a unique or a distinct function, depending if you're on Python or SQL. and see if the categorical data is consistent or not. You also want to run maybe a very basic exploratory analysis, maybe make a couple graphs with the data, see what's going on, see if there's anything crazy that stands up, see if there's any really weird outliers that you need to address in the next phase. And, and just all in all, see all the data you have, make sure you understand it, all the variables, make sure you know where it all comes from and how it all can be used. All right, so next phase is the data preparation phase. This phase is the most exciting. I'm kidding. It is the most time consuming. So here you're going to be preparing the data sets for modeling, which sounds pretty easy, but there's actually a lot of things you have to do in order to do this. So first thing you have to do, you have to select the useful data. So you know what insights you want to come up with from your business understanding phase, phase one. So here you want to select the data that will help you accomplish that, and make sure you know which one it is. Next, you want to clean the data. So whatever data that you discovered was dirty in the last data understanding phase, here you will address it and clean it. So if it's numerical data, this can get a little complicated, as you have to decide whether you want to get rid of it, get rid of a whole row if it doesn't make sense. Like, all right, let me back up a little bit. So, for example, if you're looking at numerical data, you run a basic descriptive statistics, and you see that there's a maximum value of like $10,000 for an item in a grocery store. You want to look into that, see why that's there, and then here you will be addressing it. Do you want to completely remove that row because that doesn't make any sense? Do you want to replace that price with a number that makes more sense, like maybe the median or mean value of other items in that category or other items in its section? Um, do you how else do you want to do it? So, like maybe it will depend on how big or small your data set is and the kind of what other outliers are happening in this data. Yes, here decide what you want to do. And also, if there's categorical data, you want to make sure that all the categorical data is consistent. So, and you found out in data understanding if that data wasn't looking good or if there was something off about it, you ran the distinct or the unique function, whatever you needed to do. Here, you are going to clean it and address it. So, for example, if you have a gender column and you have, it's supposed to be just male, female, two categories, but maybe there will be like male, female, and then from another survey they got like M, F. Another survey they got capital letters female, capital letters male, and then lowercase. Anyways, you want to decide on one format of those for that, and then you're going to change the rest of that category so that it is nice and categorical and it makes a lot of sense and it's much easier to calculate. All right, so next phase, all right, not next phase, sorry, we're still in data preparation. Here, you want to also derive new useful values you'll need from the data you have. So, for example, let's say you're looking at population data. Maybe you just want the percentage of males in a population. Here, you'll have to make a new category and calculate the percentage. Do the percentage or do the number of males over total population, whatever you need to do. So, and then you also, in this phase, you also want to integrate the data or combine the current data sets into one useful data set. Might make it a little bit big, but it will be a lot more useful because you can do all the calculations on one page, and you can use the data from other data sets and compare them to the data of other data sets. Maybe you need that is necessary to come up with the insights you need. So yes, you're doing that. Next, you also want to check the format. So you make sure that all of the columns that need to be integers are integers. Want to make sure the same thing with strings. So the strings you'll be applying to data that you can put into labels. So, for example, the male and female, that would be a string. Sometimes numbers can be strings, like if there's like group numbers, like group one, group two, group three, and you're not going to have to perform any mathematical calculations on this, or you don't need to know which one's bigger and which one's smaller. Like if group four is the same as equal pretty much to group one, then yeah, that can be a string. Integers, you will want to make sure columns are integers if you will be doing calculations on them. And etc. So next phase. Phase 4, we are on the modeling phase. Now, this really is the most exciting phase, in my opinion, anyways. Here you will be trying to make a model that fits the data that you have. So, just to review the definition of a model mimics the real world. It is a simplified description of a system or process to assist calculations and predictions. And again, sorry about my cat. Oh, for example, one of the most popular models I've seen recently is the level of CO2 with temperature. So, as you, this can happen in the real world, but you don't really, there's so many variables that affect both. But once you see clearly, like a data set that shows just CO2 levels and just temperature, you can see how both affect each other and run an analysis on that. So it mimics the real world, but it's much more simplified so that we can run direct calculations on that. All right, so anyways, some other things you will do in this modeling phase. You'll be doing an exploratory analysis, find general trends in the data, just do a lot of experimenting around with different maps. You want to select the useful variables, or you already selected the useful variables, but here it will be even more selective, selecting the variables that help come up with very valid um, insights that help with your business insights. Here, you will also be selecting the model finally. Let's see. Here, Python and R are two common modeling tools, for example. Let's see. So, next phase, phase 5, is the evaluation phase. Here, you'll be taking a bit of a step back and look more broadly at which model best meets business needs. And then, not only that, you want to figure out what to do next. So, from the last phase, you have a model, you have a couple models maybe. You want to look at the results, evaluate them, figure out, review the process, see how it went, see what was good and bad about it. And then you want to determine the next steps. So maybe figure out like an answer to these questions. So maybe, let's see. So for example, if you're trying to optimize prices, you see you made a little graph and you see that there's a lot, like people will pay more money on a certain day. Like let's say you're in a retail business and pay more money on a certain day. You find that out in your data analysis. You want to figure out the next steps to best use that data. So depending on the situation, maybe you can find a good thing to do with that. So if you have something that you can do in response that makes the results a lot more relevant and a lot better and more useful. So it'll be good if you know what you can do with these results. And you also want to make sure that you're prepared to launch it and that the model is effective and that the model is robust and accurate. You don't want it to be like matching every single data point, or else that will be too complicated to make a model out of or do anything about. You also don't want it to like just be like missing a lot of data points. So, or else that's like not gonna do much. Even if you have a good plan to meet that line, it might not be very effective if most of the data points don't actually follow that. So just make sure that the model is good. And last phase, phase 5. This is the deployment phase. Oh, I'm sorry, this is phase 6. Phase 6, the deployment phase. Here, you are going to generate a report and make sure that this data mining process is repeatable across the enterprise. So here, you want to take another step back, look at the project as a whole and make sure it can be used in the future. When you're writing your reports, make sure that you are clear, you are concise, and it's neat, and it doesn't give anyone a headache when they try to read it, and make sure that everyone can understand it if they were to read it. So here you want to make sure that you have a plan to deploy this plan, or a plan to use this model, make sure that it's able to be deployed. You also want to plan for monitoring and maintenance in the future. So a lot of our values are the same now, all the variables in this data set now. Who's to say it's not going to change in the future? Populations are always growing, inflation is happening. Just make sure that you take that into account and you have a plan so that people can go back in and either change variables, add something to that, whatever you need to do. And yes, produce your final report. And you also want to review the project overall, like what went well in this process and how can it be improved in the future. So one of the cool things about the Christian method is everyone is doing the same thing. If everyone is looking at the project or the standardized procedure and thinking of how it could be improved in the future, then has a lot of possibility for improvement. And that would be very cool. All right, so question two. Explain what needs to be done before you can forecast time series. In other words, what does time series analysis involve? All right, so just quickly going over what time series is. A time series is an ordered sequence of values of a variable at equally spaced time intervals. So here, time will always be on the x-axis, and then one other random variable will be on the y-axis. So usually this will be a univariate thing. You'll have one variable that compares with time. You can make a multivariate model, but that's very complicated and it's generally recommended to split that up and make multiple univariate models than to make one multivariate model. All right, so so the main goals of a time series analysis. Number one, you want to identify the nature of fluctuations in the data over time. Well, obviously, over time, it's not usually a straight line. And we might be doing this, might be doing this, might be doing this. We'll be going over that in a second, the different components of fluctuations, types of fluctuations. And after you figure that out, you want to be able to predict future values. Sorry. All right, so in this case, one of the things that you will be doing is determining whether data is stationary or non-stationary. So if the data is non-stationary, you need to make it stationary. Now, just to review these definitions, a stationary data set is data where the mean and variance is constant over time. Non-stationary, the mean and variance or covariance is changing with respect to time. So in the first step of the time series analysis, you will be dealing with the stationary part here, or you'll be determining if it is stationary and if not, why isn't it stationary and exactly why isn't it stationary. All right, so to see the nature of the changes or fluctuations in data, you need to look at 4 components. 1, trend, 2, seasonality, 3, cyclic variations, and 4, random or irregular movements. All right, so first, let's look at trend. In trend, there's no fixed interval, and any divergence in a data set is a continuous timeline. So here it'll be changing, but changing continuously and in one direction. It'll either be negative, positive, or null, the trend anyways. So for example, stock prices. Usually stock prices are going up, in a normal company or even a well-to-do company. So those will be maybe fluctuating, but they'll be generally going in a positive direction. And same with population. So next one, seasonality. These are regular interval shifts in a continuous timeline or a data in a data set. Here, you'll see in very regular intervals, you'll see a big change. So, for example, uh, or you'll see a big change in the mean or median or variance. For example, with retail, during the holidays, they have a much higher mean because everyone's buying presents for each other. So that happens once a year. So if everything else in the data set's the same except for that, once a year thing where the mean rises due to the holidays, you will want to take that into account, and that will be a seasonality fluctuation. All right, so trend and seasonality, both of those are pretty predictable and they're pretty easy to deal with. The next two are a little more challenging. So the next possible fluctuation is a cyclical fluctuation. Here, there is no fixed interval, and there's a lot of uncertainty in the movement or pattern. But one thing it does have, we do know that it happens occasionally. So like not regularly, but occasionally, and you see this sometimes. So that makes it a little different from irregularity or random movements, which happens once in a short time span. So irregularity, that'll just be just one little weird change in one short period of time. And cyclical, it could be a little bit more often. It's still no fixed interval. All right, so right. Uh, After you figure out the I'm sorry here. After you figure out the exact nature of its uh, stationarity or non-stationarity, you're going to want to build a model. So, and this model will help you predict future values. There are a couple different models. There's like an AR model, an MA model, an ARMA model, an ARIMA model, and exponential smoothing. I'll go over just a couple of these just real quick. Now, an AR model, that is an autoregressive model. This uses values from the past to predict the future ones. This one, you often use PACF or ACF, partial autocorrelation or autocorrelation functions to help predict these future values or from the past values. And another one, the moving average model. This one uses error from the last predicted data point compared, no, it uses the error between the last data point and the prediction of that last data point. And it uses that average to predict the next data point. This one kind of acts to smooth out noise and removes non-deterministic and random movements from the series as well. And let's see. Oh, yes, and this one you can also use the PACF and ACF functions to find the inputs needed for these, the P, Q, and R, for the MA or the AR model, actually. So the ARMA model, is the autoregressive moving average. It pretty much combines AR and MA. You are using past values as well as the ADA, the error from the predictions you made in past data values to predict the future values. And then the last one is the ARIMA model, which adds an I to it, which adds integrated. So the only difference between ARMA and ARIMA is that ARIMA will take the difference or integrate some data to either smooth it out or make it stationary if it's non-stationary. Oh, a little more complicated. All right, that was question 2. Question 3. I'm going to discuss the main principles of data ethics, as well as what companies or organizations could do to uphold these principles. All right, so in data ethics, there is fairness/equality, privacy, Transparency and accountability. Oh, transparency. Like its name, it's being transparent about the way the data is sampled, tested, and processed. So, if you are the company responsible for sampling and testing the data, you have to make sure that the information and how you did it is available to anyone that is using the data. Make sure that you have that available and make sure you know and you can send it to other people. You are not allowed to hide it. That's very unethical. So, in order to do this, companies can make sure they have documentation on what they are doing with the data, uh, how they sampled and tested the data, and make sure that this documentation is accessible to everyone that should know if they want. So, any of the companies that are using that data or anyone whose personal data that is. That is a but that actually will be getting into the next phase here, privacy. Now, in ethics, this ethical principle states that individuals should have control over their personal data. So there are a lot of issues with this today. So yeah, I'm sure that you probably read about a little bit of this, but anyways, right, back to here. So privacy laws. Companies need to comply with data privacy laws and make sure they get consent before using or sharing people's private information. So, what companies can do if they are collecting data on a website, they make sure people online have the choice to let their data be used or not. You will see that on a lot of websites. They'll be like, "Can cookie this like uses cookies? Can they come on your web? Can they come on your computer? Uh, or can this sites use cookies on your on your computer?" And you usually have the option whether just functional cookies or cookies to help like select appropriate advertising for you. So that is entirely up to you. And if they're not on a website and if the companies are getting are or if the people are filling out paperwork offline, make sure that these people are also aware that they have a choice to let their data be used or not. Don't do one or the other. Make sure everyone has a choice and everyone knows. All right, so the next ethics principle is accountability. This one states that companies are responsible for the data they collect, and they are held accountable if the private information is not safeguarded. And as soon as it is collected, let's say there is a hacker within their company and they just kind of waltz in there and look at all that data and get and steal all that data pretty much. That company is held responsible for that. So they had to make sure that that is completely safe. What they can do to make sure that is safe, make sure only certain personnel have access to it, make sure that they that have locked doors or good passwords so that other people can't get in. So, and make sure that only certain people know, and that all those people that do know are completely aware of how dangerous it is to share that data and are motivated not to. And let's see. Also, if another company, if they're sending this data to another company to, do some data analytics work on it or just outsource their workforce there, like they are also responsible if that company does something um, untoward or nefarious or something bad with that data, pretty much. They're still responsible even outside of their company. So they had to, in order to prevent anything bad like that happening, make sure that the company is reliable, make sure they have a good reputation, make sure that they have no possible reason to have any bias or any reasons to make anything different or to make the results different than what they would be if you were to look at it with completely unbiased eyes, and make sure that they are trusted. Um, yeah, I think that's all I had to say about that. Next one, last one is the ethical principle of equality. Here, you want to make sure that there is no discriminating against individuals or groups when handling data, and companies must take steps to avoid discrimination and bias. So while you're looking at this data, or before the data project starts, you should look at the project as a whole and then see if there are any possible reasons for bias, anything else, anything that might come up, and then and go from there. Make sure that there are steps taken to avoid said bias. Sometimes this might involve data encryption so that people working with the data or won't make any assumptions about what the data should be and will just look at the data as it is. Um, yeah, and that is sounding good. Yeah, make sure they do stuff like that. Make sure they take account of that. All right. So, anyways, next question. Question 4. Imagine you're an analyst at a financial services company and you have some concerns about bias in the way a predictive model was measured. How would you raise your concerns with your manager and make some suggestions for how to avoid measurement bias in the future? So, first, before I do anything, I would want to gather as much information as I could. I'd want to ask questions like, number one, why does it even matter? Will this affect the company if I do something about it? Will it affect the company if I don't do something about it? And let's see, yeah, just make sure you're aware of all the consequences of each possible action you could take. Then maybe try to understand why the people responsible for measuring it the way they did measured it the way they did. Like like ask were they trying to take the easy route? Is there like a reason they couldn't measure it a better way? Did they not have like good equipment or something like that? Or they have a limited population, something like that. And then yeah, go from there. Make sure that you are completely aware of everything. Second, I preferably would want to talk to the person most directly involved, even if, especially if they are the ones that might have possibly made the mistake. I think that this is the most polite, respectful, and straightforward thing that you can do, and it gives that person a chance to correct their own actions before it blows up and becomes an even bigger thing. So that would be good just to nip it right in the bud right there. So, however, if the problem is really serious or the potential consequences are just like catastrophic, like a real PR nightmare that might come into account here, you might need to go to the boss or the HR and explain it to them directly why it's such a big problem. Either way, whoever you're talking to, I will make sure to rehearse what I have to say and focus on asking questions rather than making accusations. That can be wrong in a lot of ways, just jumping into making accusations. It'll make you seem like you are an angry, bitter person, and maybe you have the bias, number one. And number two, it's just plain mean. Maybe you are wrong. Maybe you need to be asking questions so that you can draw answers from whoever you're talking about and see what other possible answers there are. So yes, and avoiding measurement bias in the future. So in the future, we can add to our data preparation routine and make sure you have a standardized approach to avoiding measurement bias. So normally you would, while you're looking at the data, make sure you know how everything is measured. And if you don't know, make sure you know how to find that information and go about find that information. Make sure you ask the right people about it. So if I was the boss at a company, I might require like a measurement bias report at the beginning of every new data project. Like it would just be like a sheet of paper with like, the different data sets you're using and then just like a little sentence on how each one was measured, just so we know. Maybe a paragraph depending on how complicated it is. And yeah, just make sure that people keep doing that and that no measurement bias problems happen ever again. All right, so question 5. Explain the difference between regression and classification models and predictive analysis. When should you use one of these models over the other? So let's start with the classification model first. Uh, Classification models use discrete variables, or variables that fall into a certain number of categories or don't go in between numbers. There's yeah, like they're like with labels or values that are like certain labels. So classification models, they kind of predict what category or label an entity will fall into or what label they will have based on a set of predefined features. So, for example, well, actually, let me talk about some classification techniques. Some of these include clustering, like on a graph, you see like maybe data points clustered in certain areas. Clustering, decision trees, excuse me, slowly filtering out a population into different categories, more and more particular categories as you go down the decision tree. Random forest, which is a whole bunch of decision trees, and then K nearest neighbors. Oh, sorry. Lots of talking there. All right, so some classification. Oh yes, so some examples on when you would use a classification technique or a classification model. Um, Maybe you can use it to identify which customers will buy a product. Maybe which customers will default on a loan based on certain conditions. It can be anything from demographics, like maybe 26-year-old or people under the age of 26 are more likely to default on a loan rather than people over 30, so like models such as that. And you can also use classification models to filter out spam mail. They have certain labels. They can see words. Uh, there's like certain buzzwords that will make labels for certain things that act as labels and will tell you the probability of that being a spam mail. And I could imagine that being in a decision tree of some sort. Like does it have the word um, sponsored? Yes. Does it have the word unsubscribe, please, at the bottom? Something like that. Does it have a Walmart logo that doesn't look like the actual Walmart logo? I don't know how they would make that in word form, but anyways, yeah. No, those are examples of classification models. Anyways, the next one we're talking about regression models. This is working with continuous variables. Uh, Here, this will just show how one variable may affect another, and then you're going to be making predictions based on that. So the most popular example of a regression model would be, at least in my um, in my readings, be the CO2 levels versus the temperature again. You see one variable and how it is, and how the other variable affects it. That is an example of regression model. Here, you will be using regression models if the target value is a quantity or a probability of a binary category. So the first one, the classification model would use if it's a binary category. So for example, um, will this customer buy this product? It'll be a yes or no classification. But if you're going to use a regression model, maybe you're wondering the likelihood or the percentage of customers that might buy this product overall. So it'll be you kind of look at it in a different way or use different values for that. Excuse me. And some examples of regression models is that the relationship between CO2 and temperature, like I said before, using that to predict climate change or when that might happen. The relationship between production demands and labor requirements. The more production you need, the more labor you need to produce the to produce your products and meet the demand. It can also be used to determine the best prices for products. So maybe look at the nice like supply and demand curve. I don't know, yeah, kind of way in the meet where it meets in the middle. And yeah, the most popular regression models are linear and logistic, using logistic on the axes there. All right, and those are the 5 questions I am going over today. So, thank you for listening. I know this was a very long video, so I really appreciate your patience listening to this. All right, have a wonderful evening. Bye bye.